name is Ilya Konik. My student number is 101460488, and today I will show you assignment number 3 for neural networks Python course. So let's actually begin with just scrolling through the code and see that everything is compiled and already run. I'm not going to do this in a video as training some of the models took 7-8 minutes, so it takes a lot of time and it's definitely not going to fit in a video. And I will just begin by discussing the code and showing the results to keep the video in a time limit. So basically here we have some imports, then we get the image, then we virtualize the content of that image, and basically here we transform it to the image array, and then we plot the image that we get, which is basically this car. Then following this we first of all show the shape of our current input image array transform, so you can see it here, and as well we compare channel 0 of our input. We compare channel 0, 1 and 1, 2, and obviously it is false. Following this we plot the channel 0. In this case it will be the yellow green part of our input. Following this we actually visualize just the values inside our resulting input, right? So that's basically, I believe, that just showing the input, which is not really interesting. Following this we we start to work with kernels, which allow us to modify images and to make them more fitable for work. And so basically this one, the first one, it does not really make any shade, shape or lines changes. So basically after we apply it here and plot, we can see that the car looks exactly the same, so the shades and everything is kept the same. Following this we do some filtering just in case to remove any values which are not within our expected 0 to 255 range. Following this we define a function which will allow us to easier work with kernel modifications. Basically following this we will use it multiple times to try out different kernels. So let's begin with this one, which will allow us to define the horizontal lines. As we can see, these values are -1, and these values will make our horizontal lines more defined. So as we can see on a plot, it's better defined. So moving forward, this will allow us to define 45 degrees lines. So as we can see, that's what is happening on our plot. Following this we have 135 degrees kernel applied to our input data, and as well we can see the lines output here. And following this we have some other modification which allow us to let me actually remind yeah, what's this one? And blow up across. Yeah, and basically, yeah, we apply this kernel here, and we has this picture. I don't really remember what this picture actually does, but still I believe that's fine. And this one will define the lines output better, so we can see that the lines are way more underlined. The shape, I actually memorized. So the shape of the object, and here as well the shape of the object, the lines outside are more defined, and we don't really care about the inner that much. And as well the last one, where we are actually concerned about lines really much, so we put a big value in the middle and negative around, so we can see the output of that application of this kernel to our input data. So let's move forward, and here we actually start to train some models. We import some libraries, import some data, and and also normalize encode some data to make it more suitable for work. And let's actually move to the part where we define the model, which is sequential model with 10 output layers, and as well we apply uh, softmax activation function at the end to map our neurons to the final layer. And let's actually, after training, let's actually see the model summary here. So basically, no need to comment, all the text is here. So following this, I believe that we are actually training the model, and we created a function which is on each fifth epoch will output us whatever the current state is. So as we can see in this case with this model training, we can see that it is increasing on the training data with a faster rate, and about epoch 20 to 25 it starts to actually not make a lot of good changes. And so as we can see that the increase in accuracy in our not trained data is actually decreasing here, but the increase in trained data is actually really more outstanding, and actually it even degraded a little bit at the end. Then we actually plot the results here, and we can see this on a graph. So it goes a little bit down here, but this one goes straight up. Following this, I believe that had some questions which I have answered here, and following this we needed to add a couple of more layers and to train our model again, and the result was almost the same here with the same trend. So I believe I will go to a plotting, and we can see eventually it even starts to degrade, but the training accuracy is actually just going up and up. However, after that, I believe the task was to I'm sorry, let me recall it. Oh yeah, so actually here it is. So the task in the final part, in the final model, was to apply dropouts, which basically turn off some neurons randomly in order to increase the unseen data accuracy, while not increasing dramatically the accuracy on training data. So as after we train the model, we can see that the accuracy of both data sets is growing way in a better relation, and we can see this on a graph here actually. So I believe that's it. Thank you for watching and for your time.